Okay, good day, Miss and everyone. I'm Chang Weishan with matrix number 205677, and my teammate is Ang Yifeng with matrix number 207277. The topic that we are going to present today is the application of nanomaterials. Nanomaterials is actually one of the topics that we have learned in material science during SEM 1. So first of all, I have a question to ask all of you. Since we all learn physics when we are in secondary school, so what should we do when we want to convert nanometers into meter? Times by 10 to the power of negative 9, right? So from the power 10 to the negative 9, we can note that how small the nanomaterial is. Okay, now let's have some introduction in the nanomaterials. So nanomaterials are materials possessing at minimum one azimuth dimension measuring 1 to 100 nanometer. They can occur naturally or can be created as a byproduct of combustion reaction. And they can be produced purposefully through engineering to perform a specialized function. They have different physical and chemical properties to their from counterparts. Next. So the contents of our presentation today will be mainly focused on the application of nanomaterials in medicine and also chemical engineering. Next. In medicine, Bernard Marcus once said that nanotechnology in medicine is going to have a major impact on the survival of the human race. And this quote is proved by the behaviors of the nanomaterials, which they have unusual mechanical, optical, electrical, and chemical behaviors. So that's why they have been widely used in medicine and pharmaceuticals. And the nanomaterials that have been used in medicine are usually known as nanoparticles, and they are being developed for the treatment of cancer, asthma, allergy, and so on. So the application of nanomaterials in imaging and diagnosis, which is also called as bioimaging field, are mainly for the non-invasive and deep tissue penetration. And the examples of the images that can be produced by the use of nanomaterial is the infrared excitation, which is NIR, and sharp visible emission lines, long fluorescent lifetime, and also the superior photo stability. Next. So there are two examples of the imaging and diagnosis in medicine by using nanomaterials. The first one is the optical imaging, and the materials that involved in OI is called the gold nanoparticles. And for magnetic resonance imaging, the nanomaterials that involved is called the colloidal iron oxide of nanoparticles. Next. Next. So nanomaterials also have been used in disease therapy. And the ability of nanomaterials to penetrate and spontaneously accumulate at biological sites by enhanced permeability and retention effect. Nanomaterials can recognize and bind to target area via surface attaching specific legend. So why the development of nanomaterials is important is to overcome some limitation found in the traditional therapeutic agents. And the examples of the use of nanomaterials in disease therapy is the photodynamic therapy and also the photothermal therapy. Next. In photodynamic therapy, the nanomaterials that involved is the photosensitizer, which the photosensitizer, they will transfer the photon energy to the surrounding oxygen molecules, which will then generate the reactive oxygen species to kill cancer cells under the irradiation of light. And for the photothermal therapy, the common nanomaterials that involved is called the carbon nanotubes, the multi-wall carbon nanotubes and single-wall carbon nanotubes, and lastly, the nanographene. That's all, and I will pass the presentation to my teammate.
So hello everybody, I'm Yifeng. So now I will bring you to the role of chemical engineering. So in chemical engineering, nanomaterial is used in prevention of microbial-induced corrosion and also is used in increasing the thermal transmitter efficiency of a pipe. So in the civil conveyor system, there will always be the microbial-induced corrosion as in the as there are a lot of bacteria, and among them there are two bacteria. They will produce the sulfuric acid. So so there are sulfate reducing bacteria and also sulfate oxidizing bacteria. So initially in a pipe, initially the pipe is covered is having the still OH2 layer, which makes the pH of a pipe to be slightly alkaline. But however, the stiff OH2 layer will interact with H2 and H2S, making it to be slightly acidic, which creates a very suitable breeding place for the bacteria that is able to produce the sulfuric acid. So later, the bacteria comes in and it will convert the H2S to sulfuric acid, and the sulfuric acid will react with the concrete pipe element to make them to become gypsum, which is very soft and makes the pipe to be heavily seriously corroded. So there are some approach to solve this problem. For example, is the spray leading. But however, the spray leading has two disadvantages. As the first one is uneven coating thickness, and also the second is the material is difficult to adhere with the pipe surface. So in the long run, the materials used to carry out a spray leading will become flex and then fall off from the surface. So the corrosion will start. So by using another materials like copper oxide nanoparticle solutions, we can carry out an electrokinesis technique to solve this problem. Since the nanomaterials are very tiny, they can diffuse diffuse into the spore and then diffuse into the concrete matrix, and then form a protective layer. So this method is better than the current approach like spray leading. So next, the nanomaterials is used in enhancement in thermal performance. So since we know that heat exchanger is very important in industrial process, as the heat is a cost, it's related to cost. So normally in heat exchanger, we use oil and water, but however, oil and water has very low thermal conductivity. So now we will have to put in some metals, and nanomaterial will be a much more suitable than normal metal, as they can suspend longer than the large particles in the fluid. So example of nanofluid used is silver nanoparticles and also fatty acid cap nanoparticles. So by just adding 0.9 weightage% of silver nanoparticles in water, it can increase the thermal transmitter efficiency of water by 69.3%. And for the fatty acid cap nanoparticles is much more impressive, as it can increase the thermal transmitter efficiency of base fluid by 300%. So it's quite impressive. So in the future, nanomaterial will surely become a most important materials and replace our current materials used in our daily life. So it will surely be used in to create carbon nanotube wire, and also being implemented in manufacturing of transistor, optics, and also used in drug emission, and also to create a longer lifespan industrial pipe. So in conclusion, nanomaterials is used in a wide variety of sector, and is very beneficial, especially is in the medicine and diagnosis sector. And also it can be used to create a better sewer system management and increase our industrial process efficiency. So that's our presentation. Thank you for listening.
8分钟上个